Hello, everybody. Good evening. Hope you can hear me. Yeah. Yes, so let's begin. Hope you're all doing amazing. This is your host, Kavya Shankar, and welcome back to Polkadot India's Substrate Saturday Bootcamp. And today we have our second guest workshop by an industry expert to give you all an experience of how real-life projects are building Web3 milestones. We are more than halfway through our journey, and it has been amazing so far. A bunch of you have been with us since the beginning and have been attending all the sessions and keeping all the sessions super interactive and fun. Kudos to you guys for picking this up super early, and thank you for making us a part of your learning journey. Do keep the streak going and hope you guys make the most out of this training. So before we start off, my colleague Asad will be sharing links of our exclusive Telegram and Discord channel in the chat box. Join in, stay interactive, and keep sharing whatever you're learning. And yes, do shoot all your queries that you have and we'll get you answered. Let's begin. So I'm pretty sure you guys have heard about Astar Network if you've been following Polkadot projects very closely. Astar is the innovation hub on Polkadot. Astar's unique build-to-earn model empowers software engineers to get paid through a dApp staking mechanism for the code they write. Astar's vibrant ecosystem has become Polkadot's leading parachain globally, supported by all major exchanges. It also offers the flexibility for of all Ethereum and WebAssembly toolings for developers to start building their dApps and to accelerate growth on Polkadot and Kusama networks. So yeah, Astar Network is made by developers and for developers. And today we have one of their best tech heads with us. Please join me in welcoming Pierre Ossun, who is a Rust developer at Astar, who is certified in Rust Substrate, Smart Contract Programming, and a lot more. And today he'll be conducting a live workshop for you guys on WebAssembly Smart Contracts, building with Ink. Super excited to have you here with us. And I'm going to stop talking now, and the spotlight is all yours.
Hello guys, it's me, it's Pierre. Sorry, I could not connect with my Astar account, so I use my personal email. But I'm ready. Okay guys, let's go. Today I will show you Polkadot next-gen smart contract on Astar, so WASM Smart Contract. I'm Pierre, I'm a WASM developer at Astar Network, and I'm building WASM Smart Contract in Ink since 1 year and a half. Please free to follow me on Twitter. My handle is Pierre Ossun. What we'll cover today. First thing, we will check what is Astar WASM Stack, as it is really different from other smart contract platform like Ethereum or CosmWASM and so on. Then we will check Ink, which is a language used to write smart contracts. Then I will go through tool and networks. I think it's really important that you know all the tools to develop the smart contract. Then I will introduce a workshop and do some live coding. What is Astar? It's an innovation hub on Polkadot. We are supporting 2 smart contract engines, so EVM with Frontier and WASM with Palette Contract, and developer incentives. It's what we call dApp staking. So if you develop and deploy a dApp on Astar, people, instead of staking directly in the blockchain, they can stake on your dApp, and then dApp rewards will be divided for the dApp and for the stakers. So it's a really great way to bootstrap project and to give funding on a decentralized manner. The question that people ask me the most is why WASM? Why this language was chosen for smart contract? And I think first I need to understand what is it. WebAssembly, it's a binary instruction format, and it's designed to be a portable compilation target. for programming language. What does that mean? It means that you have all the language that you already use that are made to be programmed by human, I would say. So JavaScript, TypeScript, Rust, C++, C#, Python, and so on. And then you compile to WASM. But WASM was not intended to be written directly in. It's actually just a compilation target. So it's just bytecode. You can actually directly code in WASM, but it was really not made for, so nobody do that. So you program in your language, then you compile, and then it create a WASM bytecode. Why it was done like this? First thing, wide language support. So any modern language can compile to WASM. You can see the full list, but for sure, if the language you're using today is compiling to WASM, of course, not all of it. Near native performance, because it was, as it was targeting to be run on a virtual machine on your browser, it was really important to have near native performance because it will be executed on your phone, on your car, on your computer. So it needed to have better performance than the JavaScript virtual machine. High portability, it was also, as it's a language that target internet for networks, it's really important that the size of the binary are really low. So when you have a low connection, then the binary will have a really small size, because it's not only execution time, but it's also size of the binary. So it was also built with this in mind. As it is, as it targets, it first targets to be run on a web explorer. It is run within a secure sandboxed environment. So there is no memory leak possible. So it is by design secured and memory safe. For all that reason, so it's near native performance. It produces really small size binaries. And you know that what is the most expensive on blockchain is actually space that you use on chain. It can be compiled and it's well integrated with all the modern language that everybody use today, especially in either like game development, web development, and microservice development. So for all this reason, it made it the best option available today to be the technology used for smart contracts. I like to say that for all the alternative that we have today, there is nothing that comes in our mind after WASM for a smart contract blockchain, and actually for blockchain in general, because you know that parachain runtimes are also WASM. So maybe in 10, 20 years, there will be something better, but for sure it will be really inspired by WASM. But it's not like WASM is not a transition towards something that will be better in the future. It's like for now, it's the best technology that you can use for blockchain and for smart contracts. Also, it's designed and supported by various industry leaders. So it's, I think, also a big giant, Microsoft, Mozilla, and Google. So the Astar WASM smart contract stack. The layer one, it's a substrate. I think if you know Polkadot, you know what substrate is. It's made of palette that consists of the runtime, and one of this palette is the smart contract engine. It's called Palette Contract. It was developed since several years by Parity Technology directly, and it's part of their frame library on Substrate. The EDSL, so the language, basically Palette Contract exposes an API, and you should have an EDSL language to be compatible with this API. So it will prevent you from writing a lot of boilerplate code, and will be way more easier for you to develop smart contract. The most famous and most used at the moment is Ink, written in Rust, and one that will be available soon for people that don't know Rust. We know that knowing Rust is not for everyone, and we don't want to have a barrier of entry of being a Rust developer. Is written in assembly script, which is really close to TypeScript. So our Web 2 developer, front-end developer will be able to write smart contract using Ask. The standard, we also have a set of standard like EIPs in Ethereum. It's called Polkadot standard proposal. Right now, there is 3 standard for smart contract, namely one for token standard, NFT, and multi-token. Some words about the palette contracts, because so the layer of the execution engine, because it's really different from the other smart contract engine. How gas is measuring in this palette. Similar to Substrate, it uses wait to charge execution time. So basically, wait is a unity of like 1 picosecond of an execution time on a hardware. So this is also used for your smart contract. So more you will ask from processing power to do your state change and to do your business logic, more it will be expensive for you to run. Additionally to this, you have a charge for each byte, and each item you put in on-chain storage. So basically, you pay for the space you store on-chain. But a good thing is that, for example, if you remove entry from the blockchain and then you save space on the blockchain, you actually get a refund for it. So it's a incentive mechanism so that people are incentive to use the less space possible on chain. Also, if you're parachain, so this does not apply for solo chain, but here Astar is a parachain, so this applied. Basically, you run your smart contract, all your state changed will be validated and the block will be produced by the collator. Then the block will be sent to relay chain for validation. This validation proof is called proof of value. And basically, the code of the smart contract, so the WASM blob, should be sent to relay chain with the state change. So the relay chain will run again with your contract code, the state change, and then validate that the block that you send is actually legit. And of course, you should pay for the more your contract is big, more you should pay because you will use network resource that will not be available for other users. So that's 3 price: the price for computation time, the price for what you store on chain, and the price for the network you use for your call are the 3 bricks that consist of your gas. What execution engine does it use? I think you're really familiar with EVM. Here, there is no mapping of opaque code. It's like a virtual machine, like any virtual machine, Java or C#. But here it's a WASM virtual machine, and we use WASM as a WASM interpreter. It's not a just-in-time interpreter. The runtime use WASM time, which is a just-in-time interpreter, but a smart contract engine is not is an untrusted environment, because anybody can deploy code there, while in a runtime the code is usually coded by the team of the parachain, so it's more trusted code. And then, in order to avoid compiler bomb and have a high degree of correctness, right now WASM is used as interpreter in the palette contracts. Also, something that I think it's a really great thing and save a lot of space on chain is two-step deployment. When you compile your contract, you will get the WASM binary called WASM blob, and then you upload this blob, so the actual code of the contract, you upload it on chain, and then your code will have a unique hash. Okay, and then anybody can, with this hash, create a new instance of this contract that will be linked to this hash. And a new instance is what? It's just a new contract address, because when you deploy the WASM blob with a hash, the contract does not have an address, does not have a storage. But one hash can have several instances, so one address, one storage, and then you interact with this smart contract. So, for example, imagine the case of ERC22. Here it's called PSP, so Polkadot Standard 22. It's a fungible token. You deploy once like an audited contract that respects the standard. You upload it one time. You have the code hash, and then anybody can create a new instance, so create his own PSP without having to deploy on chain the code WASM code again. So it will really save a lot of space in the blockchain, and also you will not, of course, have to pay for the deployment of your code on chain. So it will also be cheaper. Some word about the EDSL. So the palette contracts expose an API. It's agnostic of what language you use, and this decoupling of language layer and execution layer allow for any programming language to be used to build contract, but there is two requirements. First, it should compile to WASM, of course, and second, it should be compatible with palette contract API, but there is no restriction of what language to use. So there is Ink, a Rust EDSL, there is Ask assembly script, and there is also Solang that actually is a compiler for Solidity. I think it's used on Solana as well. And what it does, basically, it compiles your Solidity code to WASM, and then you can deploy this WASM on palette contract directly and benefit from all the feature of palette contract instead of deploying on the EVM layer. Let's have a look at Ink, because today we will code in Ink using Rust. So let me introduce it. It's really idiomatic Rust. It feels like Rust, and they use macro in order to abstract a lot of code and really focus on the developer to only write its business logic, and everything else is abstract away with macros. So here you can see on the left, basic module, Rust module with struct and implementation of this struct and its associated function. And on the right, the actual Ink smart contract that can be deployed on chain. It's like an MVP of the Flipper. And the struct is actually the storage. So this value will be set on storage. And then you have a implementation with a constructor and message that are the dispatchable function. So what macro does Rust offer? The main four macro are the constructor. What is nice is like you can have several constructors for the same smart contract. Why it is a great thing is like, as I said, you can deploy a smart contract on chain, and people can instantiate this contract because it's already deployed on chain, and they only will pay the cost of the instantiation and not of the uploading of the code. So one good thing is to have several constructors. So people that will, user that want to instantiate your contract with different option can have several constructor, so they can create a new instance based on their needs. Of course, there is storage that annotates struct that represents the control internal state. So it's basically everything that will be stored on chain. Ink message, that's a macro that marks a function as publicly dispatchable, so to be called from the outside, so a callable function, as we call it in Ethereum. And event that annotate a struct that will emit events. Tool and networks. So Astar, in collaboration with Super Colony, we have secured a grant for Swanky Substrate, which is like the truffle for WASM Smart Contract. It does not target Astar specifically. It actually targets pallet contract, so it can be used for any network that any parachain or solo chain, Substrate solo chain that has pallet contract enabled in his runtime. What is inside? So there is a CLI and a node. So Swanky node, that's what we will use before. It's a Substrate node targeting for local development. And the CLI, that's offered scaffolding, so a new project, compiling project from various languages, running unit tests, setting up RPC tests, or end-to-end tests to test your contract on chain. And of course, with key management, you are able to deploy on any network. So either your local node, test node, or live networks. OpenBrush. OpenBrush, it's a library. It targets to be like the Open Zeppelin for smart contract on Polkadot. Right now, it only supports Ink, but it will support other things in the future, I guess. For my opinion, it's even better than Open Zeppelin. It has everything that Open Zeppelin has, but even more thing. So you have all the standard implementation and the extension, and you can add it to your contract in a really easy way. You have wrapper around trades, so it's really nice. Like this, you can do cross-contract call without having to import all the code of the contract, just the trade is needed. Useful contract like, time locker or ownable, and all these business logic centric contract that you find on any smart contract. Modifiers. So modifiers is like is a business logic that is applied before entering a dispatchable function, and it ensures certain conditions are met before entering a function. So for example, it can check that the contract is not paused, and then it will actually go inside the dispatchable call, or check that only the owner of the contract can call this function. Generic trade implementation. So you can have a trade, a default implementation, and actually have several default implementation and then implement it in your contract. And of course, an extensive and up-to-date documentation. Word about our network, Astar. In blue, you have the Astar network, and in pink, you have all the Polkadot.sama network. For the standalone dev local node, we have Swanky node that use manual seal. So that's mean it will be really fast to process transaction, as it will create a block at every new transaction. So it's really handy when you do development. There is Shibuya parachain, that is our test net. And from Parity, there is contracts parachain that is connected to Rococo. Our main net, we have a Shiden parachain. It's part of Kusama, and their pallet contracts is enabled, so you can already deploy a WASM smart contract on parachain, so on Shiden. And then we have Astar, that is part of Polkadot. But right now, WASM is not, WASM smart contract are not enabled there, because the auditing of pallet contract is will start in September, will probably take some months. And then when auditing will be finished, we will be able to add it to Astar. So workshop intro, what we will do today. So environment setup, we'll of course code in Rust. So you will need Rust, cargo contract, which is the compiler that will be used for actually compile your contract, because first it needs to be compiled in Rust, then it should be compiled in WASM, then it should optimize this WASM file, and after it will generate a metadata. I don't hear you. I don't know if you want to ask a question, but I don't hear you. And Swanky node, which will be our local development node. So today we will do a really basic on-chain governance smart contract based on a governor contract from OpenZeppelin. What we'll do, we'll create a proposal, which will be a grant submission of native token. So we just have to do two things: address to receive and amount. So we of native token. So we'll just create a proposal, and if this proposal passes, then the account that we set in address to received will receive a certain amount of native token. Then of course we'll be able to vote, and anyone can vote either for or against. There is no blank vote here. You are forced to vote either for or against. So it's quorum. So it's 60% of a governance token total supply. Here we are in a test environment. So you know, there is Alice, Bob, Ferdy, and so on. Usually in on-chain governance system, like one really famous is Uniswap, of course, is set at 4%. So if 4% of token holder based on the governance token total supply voted, then we can say that this proposal can like can go through the approval process, and if it's against, then it will be closed. We will have 3 messages, so 3 dispatchable function: 1 to propose, so to submit a proposal; 1 to vote, so people can vote for or against; and 1 for execute, that of course will check a lot of things. And if everything is okay and quorum is reached and there is more for votes than against vote, then people will actually, the address to receive will receive its amount. We will have 2 contracts, so 1 governor that will host all the business logic I described, and of course a basic PSP22, which is a ERC20 equivalent of governance token. It's just a token that we will use for governance. So first we'll go to governor and PSP22 structure. Then I will show you the governor structure, and we'll create all the struct and enum and the on-chain storage. I will explain, and then we will go through submit proposal. The vote and execute will not be covered in this workshop, but I will of course send you the GitHub link, and then you can play with it, check the code. But basically, it's if you understand the logic of the submit proposal, it will be easy for you to understand the logic of vote and execute. Of course, we are hiring, as any parachain in the ecosystem. We are searching for a component UI engineer, front-end engineer, and DevRel, developer relationship. Okay, I think it's time to build. If everybody is ready, if you have question already, I can take some question.
You guys can feel free to unmute yourselves and ask your questions, or you can drop in the chat box too.
Pierre, I have a question.
Yes.
So yeah, just curious, when would you suggest a Web3 developer to use smart contracts over Substrate, and probably what are the differences that we might find according to you?
If you want to build an app, you have, of course, many things to decide. First thing is, do you want to do it in Polkadot? If the answer is yes, then you would still have 2 options. Do you want to do it in parachain level, or do you want to do it in smart contract level? There is a lot of blog posts about it. I can send it to you if you want to go to this into details. But my opinion is that right now the capabilities of a WASM smart contract in terms of speed, gas, really cheap gas. I think if you want to go to a parachain, it's a way longer process, but you are way more free in certain aspects, and you can do like a really some business logic can only be done at a parachain level, but for most of the case, if you can do it in smart contract, you should go definitely for smart contract.
Correct. Sure. Thank you. And I'm just curious for another question, if that's all right.
Yeah, please.
So we do have plenty of security threats on the blockchain, right? When it comes to smart contracts as well. So a few of those are like re-entrancy attacks, contract decryption, and all those. So what do you think we as developers, when we are writing the code, at least I'm strictly speaking with respect to ink, need to make sure that we avoid or take precautions while writing the ink contracts?
In terms of security, I think the world space have learned a lot from already early years of Ethereum. And in pallet contracts, for example, reentrancy is allowed by default. So basically, if your you call a contract that will call your contract again, it will panic. So by default is not activated, but still you, for a certain call, you can pass some flags, like for example, you can enable reentrancy on this call. Of course, in certain cases, reentrancy is needed. For example, if you're DAO and you call transfer from PSP22, there will be a reentrancy. So for certain case, you should allow it, but the hack with a fallback function that will sync all the smart contract with a reentrancy attack is not feasible. For other security reason, I think a lot of security comes from the contract logic and not from the runtime environment logic, which was not the case in the DAO attack in Ethereum. And for this, for the pallet contract security, as I said, it will be audited. It's already used by a lot of people. Right now, we haven't seen any issue, so it's great. But it will be audited, and then all your we also work with the team that audit WASM Smart Contract in Ink. So of course, if you're a serious team that will deploy a DEX, of course there is like common sense of it's exactly the same. If you're really good Solidity developer that deploy like some live DApp, I think you can use exactly the same thing in Ink. It's not there is no like more attack vector possible on Ink than it is in Solidity. I think all these attacks are more on business logic. So it's all time the same thing in terms of security.
Right. That very well answers the question. Thank you. Yeah.
Thank you.
If it's all right, I still have one more question that I had planned, but if it's okay to answer.
Yeah, please.
So I'm just curious, as in, at Astar, what are the tools that you use to test out your contracts and parachains to do integration tests and basically like figure out what the loopholes that are there in the application and the performance of the application and all that. How do you do it? What software do you use? If you can name us any, that would be helpful.
You mean what tools we use for smart contract, or what tools we use to
for
monitor our network?
For testing. Yeah.
For testing?
Monitoring your network. Yeah. Monitor and testing.
Monitoring is there's a lot of monitoring going on, but this is done by our DevOps team. Me, I'm not really familiar with it. And in terms for smart contract deployment, as we are a protocol, we are protocol layer. So basically right now we don't do smart contract development per se, but we help team to develop their smart contract. So the tools they use is the two tools I showed, which is OpenBrush, the library, and Swanky Node.
Thank you, Pierre.
You're welcome. Okay, guys, let's start. So here, this is my cargo project. Just wait a second. Okay. So in the member, we just have in our workspace, we just have the contract folder. We have two contracts here, the governance token and the governance. Let's go over the governance token. So governance token is a basic PSP22. So PSP22, once again, is the ERC20 equivalent on WASM Smart Contract for Polkadot. It's made by a Super Colony team and is part of OpenBrush. So here I just, it's all time the same thing with Ink. You have also ink dependency. Here I use exactly 3.3.0. Right now it's 3.3.1, but there is not much difference. And version 4 will come in 2 or 3 weeks, and this one will be a really great release. So if you like ink, please check this for ink 4 release. And here I import OpenBrush as a dependency, and don't forget feature PSP22. And here it's as it will be compiled in contract, it's a cdylib. And of course, I add OpenBrush to my standard dependency. Inside the contract, it's basically I just copy paste the code from OpenBrush implementation. So I will not really explain it, but it's a basic PSP22. There is PSP22 and PSP2 metadata. Here in OpenBrush, you basically just import the default implementation for your struct, and then it will add all the associated function from PSP22 and PSP22 metadata. I will let you check out on your side. Here you need to set 3 fields for metadata: name, symbol, and decimal. Our node, Swanky node, use 18 decimal, so it would be easier if I use 18 decimal here. Governance token for the name, and symbol gov for the trigram. Then, of course, I pass a total supply, and I call mild to mild total supply on the color. So we'll, of course, deploy it with Alice. So Alice will get minted the total supply. So this is really a basic fungible token that we will use as governance token. Now for the governor. So it's developed by me. It's really an example contract. We import all ink dependency. We import, of course, scale info. This is needed. Of course, I will use OpenBrush, but I will not use here PSP22 as an implementation, but I will use the wrapper around trait. So with this wrapper, I can do in a really easy manner cross-contract call to the PSP22, for example, to check the balance of an account or to transfer token. But here we'll just check total supply and balance of the account. It will be compiled to a contract. It's a cdylib, and here exactly is the same std dependency. And here, because of Rust, we need to disable overflow check, or the WASM will not compile. Okay, so now let's go to the contract. First thing here, line 1, we have config attributes. So this is to do conditional building, because first it will be built in no std, because WASM compiler only use no std library. So you should build in no std. But to build metadata, it will be built in std. You use inclang as ink. This is the only import statement you need outside of the contract. Then you have a module that have the ink contract macro that will add everything it needs when you will compile as a boilerplate code. And if you want to check it, you just need to check ink directly, and there is all you need to know. But it's pretty advanced, so I will not cover this. I should import from ink storage everything, and mapping. Mapping is like a basic map that you will set on storage. And of course, from scale, you need encode and decode because it uses scale as in Substrate to encode and decode type for calls and to store on chain. So right now we'll start to write. So we will create one enum vote type that will have two fields for and against, a proposal. So as I said, a proposal will have a so it will be an account that will receive the money, an amount, so the amount of token he should receive. Of course, voting period, so vote start and vote end. And if it has been executed, so of course it will be false. And then when it will be executed, it will become true. Then a proposal vote. So just to track the proposal vote, so against vote and for vote. Proposal ID, so to have in the mapping the proposal to the proposal vote and the proposal. And then here we'll go through what we will store on chain. Okay, so let's go. So pub-enum so for against type. So here, as this enum will be used as an argument for a function, it should implement encode and decode. And also it will be part of our metadata. So it should derive type info. So that's why in all the enum and struct used in Inc, you will almost all the time, if you use it on storage or if you're using for your arg, then it will implement encode, decode, and type info. Then the proposal. So it have a two, the amount or value, but I think amount here makes more sense. So let's start. So timestamp is actually it's a Unix time. So it's in millisecond. So 1 second is 1000 timestamp. And of course, executed, which is a Boolean. In order to make timestamp use more easy, I'll create a const that I will call it 1 minute. Timestamp is a U64, and it will be 60, not 1000, because it's in millisecond. So it will be way more easy to use 1 minute than to all time do this. So proposal vote. So you can either vote for or vote against. Keep in mind that here it will not count for vote as 1 if you vote for 4. It will actually use your weight. Your weight, it's like the portion of the total supply of the governance token that you hold. For example, if you hold 50% of the total supply of the governance token, your weight will be 50. And other quorum should be 60. That means that if you hold 60% of the total supply of the governance token, you have all the right on the network. And it's what it's used usually in the all on-chain governance that use governance token as voting power. Okay. Then we have proposal ID. I think it's U32. It will not be so much, but usually U32 it's quite the standard. Now we'll go through the storage struct. This one is really important because as a smart contract developer, you should all time think on how can I store on chain the least data possible, because this is a really scarce resource on chain. It's really expensive, so you should do as much. You should really increase efficiency of your contract by saving on chain least data possible. So let's see. Usually we call the data struct with the name of the contract. So here, governor. Okay. So let's go one by one. I will explain. So first field, proposal vote. It's a mapping that will track all the proposal vote. And each proposal will have, of course, an ID. So you will have one proposal vote per proposal, basically. Of course, actually, I could put this in first. So you have proposals, which is a mapping of proposal here, and proposal ID. Then you should track, for example, you have your proposal, then your proposal vote, but you should also track who has already voted. And if someone has already voted, of course, he can not vote 2 times. So you should track who has voted. So basically here, I just have a mapping, and the key will be the proposal and the account. And every time an account will vote, I will add a new entry, and the value is empty. This is a really efficient way to do it, because then here there is no way for me to add a bool that will use 2 bytes of memory. I can just directly use as a key 1 byte as a key, and then if this key exists, then that means this account has already voted, and if this key does not exist, then that means this account has not voted and can vote. Here, next proposal ID. So it's a really handy way here when the mapping does not know what is stored inside. Okay, so every mapping will just be in storage, just a key value stored on chain, but it does not have info of how many key value there is, and is not iterable. So in order to ensure that every proposal ID we store does not exist already, we just track it, and then first it starts at 0. We store proposal ID 0 in storage, and then we increase it by 1. And we do this every time we create a new proposal. So the quorum, which is in percent, so U8 max is like 255. So as we only need 100, we do not track like a really, we do not track percentage with decimals. 1% is 1%, there is no 0.1% here. And of course, you should specify a governance token. So when you will deploy your contract in the constructor of your governor contract, you should specify the address of the governance token, and then it will query the balance of the total balance and the balance of the user to calculate his proposal weight. Of course, it's a ink storage, so it should derive ink storage and also spread allocate for mappings. And here, so this is our storage struct, and we just implement the storage struct and give to this struct associated function. So the first one is, of course, the constructor. So it should have this annotation constructor. And here I added payable. So that means that this function, callable function, you can actually send native token to this function, and it will be transferred from the account that called the function to the contract. It's exactly the same as payable in Solidity. And as here, basically, we will create proposal to fund people. When I will deploy it in the constructor, I will, of course, send money to the contract. So it can send, transfer its native token to account that will have a proposal. Of course, I should also use a quorum, but here it will be 50. So here, the contract will not compile if I don't have at least one ink message, so one dispatchable function. So here it should already compile, but for sure, Rust, it never compiles the first time. So right now I'm in governance token. I will go to governor. And then to build the contract, I used cargo contract, build. And here I should pass release flag, because here I will not use, if I don't use release flag, it will compile in debug mode. And here I just don't log anything, so I don't need to compile it in debug mode. Okay, I have some typo. Okay, here, as you can see, type info should be added to proposal vote. I totally forget this. And as proposal and proposal vote will be stored on storage, it should derive encode decode, but also spread layout, pack layout, and spread allocate, because it will be used in a mapping. And of course, for STD, it should derive type info to generate metadata, and also storage layout. There's some typo. and now it builds. So let's try to code propose to submit a proposal. Is there any question for now on the structure of the contract, on what should be stored in storage and so on? No, okay, so continue. Here, as you're in the impl block of your struct. Of course, you can actually use this struct, and basically this self is what give you access of all the fields of your struct. And the struct are stored in storage, so you can basically use and self, a reference to self, to actually access all your storage entities. There is a rule in Rust. So here, if I only use reference to self, I cannot mutate it. So when you use a reference to self, you use it for queries because you cannot modify the struct. Here, when we propose, we'll actually store on storage a new proposal. So we should use a shared mutable reference to self. Of course, we should specify which account ID will reserve money. We should specify the amount, which is balance. Balance is basically the type used. It's basically the type used for money fields, and under the hood it's just a 128. Then a duration, like in minutes, so it's a timestamp. Let's use 64, and of course it will return a result. Really idiomatic Rust of nothing, of empty, and a governor error. So governor error is a struct, and we should, of course, create this struct. So at the end, it only returns okay if everything is working. So governor error, basically it will be the error, the enum that will store all of your error type. It's really handy. So here I just copy pasted it's all the error that this contract will be emitted, and of course it should derive encode, decode, and type info. So what we should do first, there is a rule in all smart contract is verify first and write last. So first we should do a bunch of checking so that user ensure that user is not malicious, and also that user did not make a mistake that he doesn't want it to do. So of course, first we need to check that amount is not 0, because there is no like sense to have an amount of 0 for a proposal. And then if amount is 0, then we return actually an error of governor error. Amount should not be 0. Okay. Second check, the duration. Here I want the duration to be, of course, more than 0, but it's inside integer, so it cannot be behind 0, but I don't want it to be 0. And also I want it to be less than 1 hour. So if duration equals 0, duration is more than 1 hour, then I should return no error, duration error. Okay. Then as the start date here, it's a duration, but start date it's actually now plus duration, and end date will be now plus duration. So now how to access the time? Ink has an API to call on-chain values. So it's called self.env, and here you access the time with block timestamp. You can check ink env API if you want to know all call you can do to runtime. Then we'll create the proposal. So 2 will be the address we pass in as a argument, amount as argument, what start now, what end now, plus duration. So duration is in minutes, so time 1 minute, and executed false. But here, when we store in storage, we should store the proposal ID. So we should also get the proposal ID, and we already have the proposal. I will create an internal function that basically this ID, first I need to query it to get the actual ID, and then I should increase it by 1 and store it in storage, basically the actual plus 1. So every time I call this function, it gives me the actual and it store in storage the next proposal ID. So we don't need here, it's not an inc message, it's like a private function, internal function more, because I don't use a private function. Of course, it's a mutable self because I will store in storage next proposal ID. So first, to query the ID, I just use self dot next proposal ID. Then I increase it by 1. So self dot next proposal ID plus equal 1. And then I return the ID. So here, let ID equal self dot get next proposal ID. Okay, and now I did all my verification. I created my proposal. I get the ID, so I can finally save this in my storage. Proposal dot insert. So ID is passed as a reference and value as reference as well. And here we submitted our proposal. So propose is not actually the right word. I just noticed propose is when you are in a wedding and you want to propose. So here it's more submit, but actually in a governor contract of OpenZeppelin, they call it propose. So I said the same. So here, for all of the other, let me share you this in chat. So I share in chat the GitHub. Let me show you, because I will not have time to go through the coding of the other, but you have here execute, and I mean, you have execute and you have vote. So you can try it yourself. And here you have a query. I will explain this as well. Get proposal. Let me back to the code. So this will be like a call that will modify the state. But if you want to do a query, for example, to get a proposal and to get what is inside a proposal, so you pass a proposal ID, and basically you get the proposal like a 2 amount, duration, vote, and so on. And here I just pass reference to self, and of course I return an option, because I don't want to return 0 if it does not exist, because proposal ID 0 will be used. So it's more there is more sense of using an option here, and if it doesn't exist, we'll send known, and if it exists, it will send some of the proposal. So this is how you do a getter, because in Solidity, when you create a storage variable, then the getters will be created automatically. It's not the case in Ink. I think it's better so that you can actually create your own getters, but you should not forget them. Let's build again. I think governor is already okay. Now I will run. I have swanky node. So this is a dev node. You can either download the binary directly and zip it and run it directly, or download the code, cargo build release, and then you use it. You call it by using dev and temp flag. Now, if I go to Polkadot.js, and I go here to development, local node, I switch. Here I go to developer contract. So here I already tested this morning. Of course, all time ensure it is working before the demo. But here, as every time you run dev temp, it will create a new on-chain storage. So this is a cache of my browser, but actually this does not exist on-chain. So first thing, I need to upload my governor contract, because I should have it to my governance token, because I should have my governance token as an argument of the governor constructor. So here, when you build, you will have a target folder. Target folder, you go to Ink, and here you have your two contracts. And then you have 3 important files. So the .wasm, which is the WASM binaries. You have the metadata, which is the ABI, the metadata, and the .contract, which is actually the WASM and the metadata. So it's really handy when you want to use it to deploy and to interact with it using Polkadot UI, the JS UI. So here I take my .contract, and I add it here. It's my governance token. I I use Alice. I will give 1,000 to Alice. And then I have my governance token here. Then let's deploy governor contract. Sometime, I don't know why it's not working well. Okay. Okay, I will do by hand. So, okay, so here, this is my governor contract. So my governor, so here, this is my governance token. It's not Bobstash, it's governance token. So the quorum, here I'll put it to 50. And here, as I told you, it's a payable constructor. So here, I actually send a token to the contract from the deployer. So Alice will send a native token to the contract. Then I can deploy. Okay. So here I have my governor. I have two functions, propose and get proposal. If I get proposal 0, it says none. Of course, it was not created. Let's create a proposal. So Alice to Bobstash, amount 100 and duration. Let's put duration 0 and let's see what's going on. So here I can use read contract only, no execution. So basically, it's what we call a dry run. This is the only way to know if the contract send error. And even if you do integration in your front end of Ink Smart Contract, the best way is you do a dry run. If it send back okay, then you do the actual transaction. Because if you do the transaction directly and then it send you a result error, then it will not, you will not get the error in num, so you don't know which error it is. So first do a dry run. If it's okay, do the transaction. If it's error, then you will actually get the error. So here, as I put duration 0, then I get error, duration, error. If I put amount 0 and duration 10, then I get amount should not be 0. But if right now I do a transaction like here, then I will get an error, but I will not get exactly which one. So here, if I put amount 100, duration 10, and then I do a dry run, then I get okay. So when I get okay, then I can execute the contract. And then if I call get proposal ID 0, I get 2. This is the account ID of Bobstash. Here, this is 100, but as we use 18 decimal, there is 18 decimal. Vote start here, it's actually the start in Unix time. This is actually now in Unix time, and this is in here in some more minutes, in 10 minutes, I think I put, and executed false. Okay, guys, that's all for me, and I've sent it to you the GitHub. If you want to go more and to implement yourself the vote and the execute and check balance after, I think it's really interesting. So if you want to do it, please do it, and please reach me on Telegram or Twitter if you have question. I don't know if there is question about something. I have 5 minutes.
Hey, it's been very nice. Thank you. Am I audible?
Yeah, I hear you.
Yeah, thanks. So I have one question. Like, the storage item is available to everyone. So where is the lock mechanism? So for example, get the next proposal ID. If
Yes.
thousands of people try at the same time,
Yes.
okay, so what is the possibility of getting the same proposal ID to many?
Uh,
I hope I'm making it.
yeah. Every contract can only how to say can only access on-chain storage once. So that's mean if 1,000 people try to create a proposal, it will actually go to the transaction queue, and the one that pays the more fee to process the transaction will actually, here you can include the tip. So if someone include a tip, his transaction will go first, but of course it will be queued.
Okay, so by queuing, are we ensuring? Okay, queuing is the mechanism of deciding whose transaction we are going to take. So
Yes.
does that mean storage is accessed one at a time? I mean, uh, in the same for voting. Suppose some proposal has got 10 votes, and I am voting next, so the vote will become 11, right?
Yes.
So I'm adding 1 to 10. Okay, is it possible like 100 people are adding 10 to 1 and making it 11 only?
But for vote there is no problem. But it will, yeah, the same thing will be applied. All like all call will be queued, but as it's Rust, it's WASM, it's really fast. So in one block, actually, I don't know, like I would say 5,000 transaction can be done in one block. So even if 5,000 people create a proposal at the same time, it will still be queued and executed within the same block, and everybody will get his own proposal ID.
Okay,
Those are,
proposal ID. Yeah, next thing I was talking about like voting on each proposal ID. Okay,
yes.
so my logic is like I read what is the current vote, and then I add 1 into that.
Yes,
Okay,
but
so
you
if
don't
one,
add one. You vote with your proportion of your governance token you hold. So it's a weight. You don't add one.
okay,
You add your weight.
okay, so suppose for example I'm adding 1, okay,
Yes.
and somebody else will add 2. Suppose he has
Yes.
more voting power.
Yes.
So when my program is my voting is executing, that time I will read the current vote as 10 and then add 1. What is the possibility that other person is also reading the current vote as 10 and then he will add 2 to the 10 and I will add 1 to the 10?
As I said, it will be queued. So that's mean the transaction queue will take the one who pays the most. So if for example you query 2 and then you try to add 2, but then someone pay more and go before you, then it will add after it. But it's exactly the same as in all other smart contract. And if you don't want to do it, that's mean every people that send a transaction will have like a lock. And imagine how horrible it will be if every people that do a transaction will actually lock the mutable state of the contract before any other people access the mutable contract. So this thing can happen, but there is nothing to prevent it, and it's actually the same in all smart contract. But I would say it is really unlikely, I would say, but this is how it will work.
Yeah, I understand. Yeah, thank you.
Thank you.
And second question regarding development environment. So
Yes.
we are in our group currently developing on Substrate framework.
Yes. Yes.
So in your stack here, I'm not seeing any work on Substrate.
Yes.
So is it like we will not be using Substrate at all?
Yes. So you Substrate. So if you build runtime, you actually either building a custom palette, or you're actually creating a runtime that is made of palettes. Here you use a contracts palette. So it's a palette that was developed by Parity, and it will be added to runtime. So here, as a smart contract developer, you don't actually need runtime, because it will be palette contract will be added by the runtime developer, and you just need to use the EDSL, so ink, to deploy on palette contract. So there is no runtime development when you do contract. You don't do you do layer 2 development, so smart contract. You don't do layer 1 development, Substrate.
Oh, thanks.
One last question? So guys, I've sent it to you the slide. I've sent it to you the GitHub. I actually have a wedding now of one of my best friends, so I need to change it. It's in 45 minutes. I was really glad to meet the Indian community. I really want to talk to you more, guys, but I have a really hard deadline today. It was really a pleasure. Actually, there's not only Indian people, I guess. But yeah, please feel free to reach out to me and ask as many questions as you have. Thanks, guys.
Thanks, Pierre. Thank you so much. This was a great session, and I'm sure we have a lot more questions coming in from the audience here. We'll definitely approach you further for all the help with it. So guys, do drop all your questions for Pierre in the Menti link in the chat box, and we shall get it sorted for you.
Okay. Thank you very much. See you guys.
Thank you so much. Thank you for your time.
Bye.
Thank you so much, Pierre.
Thank you.
Great, guys. So we shall see you next Saturday at the next session of Substrate Saturday Bootcamp. And yeah, your mentors will be their location pages. And also do not miss the question and answer session on Friday. That is the 26th of August to help you move along with your assignments. Thank you all for making time, and yeah, have a great evening and have a great weekend.